Yes, please. You're welcome to Pure Math School. Today it is a problem we're going to handle. We're going to handle the first question that you saw on the thumbnail. That's the cover of the video that you saw. We had this question, so this is a question we're going to deal with for today, and for the other two questions, you'll have to come back later. But for today, let's start off with this. As you can see, before we start handling this question, I want us to first be familiar with some of the following, and I'll explain them. We need to know that cos of negative x is actually the same as cos x. We need to know that tan of 225 degrees is actually the same as tan of 45 degrees. We need to know that sine of 90 degrees is actually 1, and we also need to know that tan of 360 degrees minus x is actually the same as negative tan of x. Let me explain, starting from cos of negative x. Cos of negative x is actually the same as cos of 0 minus x. Okay, and your cos of 0 minus x, if we go to our quadrant, let me draw it somewhere here. We have here all the trig ratios are positive. Here we have only sine, which is positive. Here we have tan, which is positive. Here and here we have cos, positive. So in these quadrants, we have this one is known as the first quadrant, second quadrant, third quadrant, fourth quadrant, whereby those trig ratios you see are positive in those quadrants. And for this case, only sine is positive here, only tan is positive here, only cos is positive here, and here we have all positive. Sine, cos, and tan are all positive. And you also have to know that they are inverse, the inverse trig ratios. That's 1 out of sine, which is cosec, 1 out of tan, which is cot, and 1 out of cos, which is sec, are also positive, just like they are. So we need to realize that our cos of negative of 0 minus x is actually 0. You know, when we are going clockwise, you need to know that clockwise for positive angles. Okay. Meanwhile, anti-clockwise means you're going negative angles. Okay. So for the case of cos of negative, let's draw a fresh one now to try to tackle that. Cos of 0 minus x is actually going to be side, cos 0 will remain on this line, since this always has starting point and we go that way. For all this could be a starting point to the negative direction, so cos of 0 minus x is actually going to be x into this direction. Okay, and you know that in that case, in this quadrant, cos is positive. That means if we simply look at cos, remember when we looked at, I explained this when we were looking at trig ratios of acute and obtuse angles. I think you can go back and check the previous videos. I think it's video 0.6. You'll try to check in there, and you realize that here our cos is positive, so it's cos of 0 minus x is actually the same as cos of x, which implies cos of negative x is actually cos x. I think you've understood that for the case of cos of negative x being the same as cos x. Okay, let's move on to explain for the case of tan of 225 degrees. Okay, tan of 225 degrees, we are still going to use the same quadrant, which is going to help us. You know, 225 degrees for us, if you're measuring, we'll go through 180 degrees and we add another 45 degrees. Okay, so that tan of 225 degrees will actually be, in this quadrant, you know that tan is positive. We have 180 which has been completed here, but we have only 45 degrees here. Since it's in the third quadrant, here we have tan positive, as you can see up here. Tan is positive, so we're going to have positive tan of the angle that remains with the horizontal there, which is 45 degrees. Even if you check from the calculator, you realize that it's actually like that, but for this question we are not supposed to use a calculator. And I need to also prove to you that tan of 45 is actually 1. Remember, 45 degrees comes from a unit square of each side 1 unit. Okay, 1 unit. Then we draw a diagonal there to split, which here will be 90 and here is 45 degrees. Since that diagonal splits that 1 unit square into 2 equal parts, this remains angle 45 degrees. Here 1 unit, here 1 unit, and here will remain root 2. If you get the from Pythagoras theory, you realize that that hypotenuse is going to be root of 2. Now what does it mean tan of 45 degrees, which is this angle? You know, tan is given by opposite out of adjacent. If you go back and check our soccer tower, okay, you come to tan here is opposite out of adjacent. So our opposite will be this one, which is 1, out of adjacent, which is still 1. So our tan 45 will actually be 1. So I think we have dealt with that. This one up. We have here, this one is okay. This one is now equal to 1, which is also okay. Now let's go to sine 90 degrees, okay? Sine 90 degrees actually is given, you remember when we were looking at trig ratios of obtuse angles for this time, obtuse angles are actually those ones between 90 and 180 degrees. We looked, I remember in that video, I think you need to first go back and check it once again. In case you're new to the channel, please go back and check, and you need to subscribe also in order to follow more videos. So we realized that we had something like this. We had a triangle where here we considered it to be actually we here considered this angle to be x, which was unknown, and here to get this angle, since this 45 degree, this 90 degrees, this x, that angle will definitely be 90 degrees minus x. Okay, and we had to give these vertices a, b, and c in that, according to that. Then we said our sine of 90 degrees minus x, okay, would actually be here what? Our side of 90 degrees minus x would actually be opposite. You know, sine is opposite, which is going to be opposite out of hypotenuse. Remember our soccer tower from there. Opposite is going to be that which is opposite to that angle, which is AB, out of hypotenuse, which is going to be BC. Okay, but then how do you get sine 90 degrees? Sine 90 degrees is obtained is when actually x tends to 0 degrees. Okay, it's obtained when x tends to 0 degrees. And when x tends to 0 degrees, what happens? When angle x tends to 0 degrees, we realize this, as this x tends to 0 degrees, you realize that even 90 minus x will tend to 90 degrees. Okay, 90 degrees minus x will tend to 90 degrees. Okay, and then that side AB will actually tend towards this length. Remember that AB is going to go towards 0. AB, okay, AB will tend towards we are going to have, for the case of since it's a sine, we will need only that angle, and we need its opposite and its hypotenuse. So for that case, let's not consider so much. That angle will tend to 90 degrees. Remember, as this one tends to 0, that angle you see there will be tending towards 90, since that one will be gently going until it's at right angle to that side AB. Okay, so that 90 degrees minus x will tend to 90 degrees. And also as that one goes like that, that length BC will tend, okay, length BC will tend to become this one here. That length BC will just become AC. This length AC, if you can see, AC. Okay, so it's going to be AC. Sorry, actually here we had a tan of 90 minus x. Sine of 90 minus x was going to be opposite out of hypotenuse. Sorry, the opposite is actually going to be AC. AC out of BC. Okay, so since since our x has tended to 0 degrees here, and that angle x has tended to 0 degrees, and 90 degrees minus x has tended to 90 degrees, BC has tended to AC. What does it mean this time? Therefore it means that sine of 90 degrees minus x is actually sine of 90 degrees, which will be AC. Remember that BC has tended to AC, which will result to 1, which implies that our sine of 90 degrees is actually 1. Okay, I think that was clear. And the final one, let's see how to handle the one of 360 degrees minus x. Still, we are going to use our quadrant. Our quadrant is going to be, we're going to go 360 degrees round, then minus x again, which will come to the opposite direction through an angle x. So that means you need to check that tan of 360 degrees minus x. In this quadrant, we have tan is, tan is actually negative, so it's going to be negative tan of the angle which has measured to the horizontal, which is x. So we have tan of 360 degrees minus x going to be given. It's going to be given by negative tan x. So that's how we can reach there. Therefore, we're going to have conclude that. Let's go and make our conclusion. We had the question is saying that cos of negative x tan of 225 degrees out of sine of 90 degrees minus sine x plus tan of 360 degrees minus x will actually be, now I said cos of negative x, we confirmed it was cos x, okay, according to the explanation, and tan of 225 degrees was actually tan of 45 degrees, which later became 1. But let's first continue. Our sine of 90 degrees was actually 1, then minus sine x, then plus tan of 360 degrees minus x actually became negative tan of x. Okay, so our next step is going to be cos of x. Then that tan of 45, we confirmed it was 1 out of 1 minus sine x minus cos of that negative, then tan x is actually sine x out of cos x. Okay, then we have there cos x out of 1 minus sine x. When you multiply 1 by cos x, then minus sine of x out of cos of x. Okay, so what does it mean here? Let's try to get the LCM. We're going to have cos x into 1 minus sine x. That's the LCM for that, lowest common multiple of these two. So that we are going to have now trying to subtract that from that. Then here we're going to remain with cos x times cos x minus, here we're going to remain with sine x into 1 minus sine x. Okay, then what next? We're going to see that here we'll have cos squared x, since cos is multiplying itself, cos x is multiplying itself, minus, when you open that bracket, we're going to have minus sine x, then plus sine squared x out of cos x into 1 minus sine x. Let's not touch that one. So that we're going to remain with what? Here we have cos squared x, we bring sine squared x near it, minus sine x. Since remember we have a trig identity there, which is a Pythagoras theory under trigonometry, we know that cos squared x plus sine squared x is actually 1. Then let's repeat, cos x into 1 minus sine x. What will happen next? We have 1 substituting the whole of this from Pythagoras theory. So we have 1 minus sine x there out of cos x. If you're not familiar with this, you can check. It's one of the trig identities that are there. And then here we're going to remain 1 minus sine x. Here you see that 1 minus sin x is going to actually cancel, remain 1 out of cos x. And what is 1 out of cos x? Sec x. Okay, so the whole of cos of negative x tan of 225 degrees, this, out of sine of 90 degrees minus sine of x plus tan of 360 degrees minus x is actually the same as sec x. Okay, did you enjoy the video? Please don't forget to subscribe to the channel, and please like the video, turn on the notification bell for more content. Please see you in my next video. Please subscribe to follow more content.